having us today. I'm Kristen, and Eric is also here. Eric was one of the original architects of this tool. So any very difficult questions will pass to him, the black belt of the Monarch Habitat Quantification Tool. We're scheduled here to go till 3 your time, excuse me, Pacific time. So we'll try and keep it to 2 hours, but know that Eric and I are available for the half an hour afterwards from 3 to 3:30. So feel free to stick around, ask more questions, and then our email addresses are on the slide and we'll pass them around. So certainly feel like you can contact us at any time with questions around any component of the habitat quantification tool. So I'm going to dive in. Eric, do you have anything to add before we start?
Nothing to add. Thanks, Kristen.
Great. So please do, we'll definitely have question period at the end. If you have an urgent question, please interrupt me, or you can also type it into the chat window and Eric will be monitoring that. So he'll have a sense of what's going on. So I hope everyone can see my screen. If you can't, let me know. Great. And just so you know, this presentation is being recorded. So contact Hillary or Nancy if you want to replay it for future entertainment purposes. Get some popcorn, set up on the couch. That'll be great. So the Monarch Habitat Quantification Tool was originally developed with support from Environmental Defense Fund as part of their Monarch Habitat Exchange program. We worked on it along with the Monarch Lab at University of Minnesota, Monarch Joint Venture, and other contributors. We did originally design it for the eastern population of monarchs and then modified it to work for the western population. So as you'll go through this, you might see a few discrepancies of just example plants and things I use that are not found in California, but know that the Western HQT, which is the user's guide that you all saw earlier, and the calculator, which you'll see after this presentation, is all translated to the Western population and that species needs. So what is a habitat quantification tool? We at Environmental Incentives have actually developed several habitat quantification tools for monarchs, for sage grouse, for Swainson's hawks. And essentially, it's a standardized approach to understand the quality of a habitat for a specific species or community. So having kind of a standardized communication device allows for more accountability and transparency. It also helps measure, track, and report progress towards conservation goals, which is very important. And it can bring in more people to the conservation pie. It can create incentives for landowners, for farmers and ranchers, and for others who just want to know what they're getting when they do a conservation project. Habitat quantification tools also allow for pretty clear comparison between sites. So instead of just saying, here's a 50-acre monarch habitat, here's a 25-acre site, you can say, well, the 50-acre is lower functionality, whereas the 25-acre site is really high functionality. So it's more like comparing apples to apples than apples to oranges. So one of the main components, and a thing that we think will be useful for you all as you work with landowners and others, is that having a clear communication tool helps bring in new folks. Working with a landowner, for example, who has a beautiful cornfield and their hedgerow, or their side field, they mow, they keep weed free. You can use an HQT to communicate, okay, if you plant these species, if you allow for milkweed to grow, you can have your property look more like this on the right and create better habitat for monarchs. And here's how we're going to measure it. Be clear and easy. Great. So we think you guys at WCB will benefit from this tool because you can evaluate current habitat quality. You can use it to inform management actions as you do site design. And then you can also monitor changes over the term of the project. And Hillary or someone remind me, how long are the WCB monitoring rules? Do you guys have to monitor for a couple of years?
10 years.
10 years. So yeah, so having an HQT can help you see how the site changes over time, and if there's a sudden decrease, it can help you adaptively manage that site to bring it back up to where you want it to be. Any questions so far? Great. So the HQT brings in several different indicators. Primarily, it looks at monarch breeding habitat and monarch foraging habitat. Breeding habitat is measured by milkweed diversity and density, and foraging habitat is measured by blooming nectar plants. Those things go into the site capacity, which when combined with the threats, mostly isn't near conventional agriculture, and its conservation priority, that's how you get your habitat quality. Your habitat quality is kind of weighted averaged over the size of your project, multiplied by the acres, and that's how you get your functional acres. So this is kind of the unit of measure that EI and EDF, when they use this tool, talk about. Instead of saying, this is a Monarch project that's 50 acres, we say it has 12 functional acres. So I'll go into each of these attributes later, but just know we do look at milkweed density and diversity and blooming forb richness and frequency to get that site capacity score. There's different units and different measurement methods, which we can also talk about if interested. But I'll hold on to that unless you guys can ask me later at the end. So each of these attributes are weighted depending on importance, and you can see here the different regions have different weights. So in the West, the breeding habitat makes up 50% of the total score, and milkweed density contributes 80% versus milkweed diversity is 20%. Similarly, for foraging habitat, blooming forb frequency is weighted slightly higher than the species richness. So then the breeding habitat and the nectaring habitat are combined in equal parts, equal weights to get that site capacity. So again, once you have site capacity, you combine it with the threats, you combine it with the conservation priority, and you get your habitat quality. So sometimes I'm communicating functional acres or habitat quality. It's good to talk about number of species, and this is based on a paper that one of our contributors wrote based in the eastern US. So it may not apply to the western US. So be careful when you say this. But we often say there's a monarch yield of 70 butterflies per functional acre when you're talking about Missouri or Texas or Iowa. That helps folks understand what they're doing when they're improving their functionality on their land. If you can improve to get one more functional acre, you're going to produce 70 more migrating butterflies. So just a communication technique that we should figure out how to check in California. So there are some limitations to our tool. It does not assess all values that a site can provide. For example, like a pond, a drinking pond, it doesn't include things like that. It doesn't include other things besides monarch habitat, like other pollinators or other ecosystem services. It only provides a snapshot. So it looks at when you are there on the site, which you'll see, it depends. If there's things blooming, you count them. If there's things not blooming, you don't count them. So it has limited predictive capabilities on what the site potential could be. It also doesn't replace objective-based monitoring, especially during a restoration period. So when you're actively watching plants grow, it's hard to use the HQT to see if your restoration project is working. And then, of course, like any monitoring technique, use reasonable judgment. There's a lot of ways you can communicate about the HQT and how you can splice it up. So use your brain. Great. now I'm going to dive into how to use the HQT. And I really do wish we were all tromping around a beautiful prairie, maybe in Solano County, maybe in Merced at the grasslands, but we'll have to just manage it as a webinar for now. My apologies. But imagine we're standing in the heat of Central California. There are 3 HQT components. The specifications document, which goes into the why and reasoning of what's in the HQT, if you want to get into all of our references and citations. The user's guide, which hopefully you guys were able to flip through earlier, and which most of this presentation will walk through. And then the HQT calculator, which takes all your site data and calculates that habitat functionality score. And the calculator is an Excel-based document. So, when do you sample? You sample when there's monarchs, when monarchs are present, and when you have good milkweed and blooming nectar plant availability. So we say here May 20th to October 1st, but it's really dependent on if the monarchs are there and using the habitat. So oftentimes if we're working with a landowner and we know we have to monitor his site, we'll just call him up and see when he starts seeing milkweed, and then we'll go 2 weeks later. Kind of base it on when you think the monarchs will be actively there, actively using the resources. So there are 5 main steps to using the HQT, and I'm going to walk through each of these steps today, and Eric's going to make sure I stay on time. So the HQT was designed, so if you were at a small site, like many of your projects, you know, 2 1-mile sites, 2 or 5 acre sites, you could do this in a day max. You could, the day before, spend an hour developing the project base map. The next day, go talk to the landowner and spend half a day in the field collecting your vegetation data. Drive back to the office, do the desktop analysis, plug in the calculator, and then you'd have your final base map within the day. It depends, of course, if you're at a big, huge site, you could be in the field for days and days. Eric recently was in, or last fall, was in Missouri on a farm, and it took 3 days to do all the field work. So just depends. But hopefully the pre-work and post-work are relatively straightforward. So first step, develop a base map. We suggest using an aerial image, GIS, Google Earth, whatever you guys normally use is great. And then you'll delineate or outline the project area. So I have just like a little mock map over here on the right. And you'll see there's a couple different fields we're assessing. We have, yeah, I'll talk about those in a moment. You don't include areas that aren't habitat, like ponds or open water. You don't assess things that are managed for things besides pollinators. You don't measure just a commercial ag field. And then you also don't measure hedgerows near conventional agriculture, because those are really used as a barrier. So you develop the base map, define your assessment areas. So you break up your assessment areas based on restoration plan, management plans. If one thing looks way different than the other, split it into a different assessment area. And then if it's a big, giant area like this area E, if it's greater than 5 acres, then you should generate some random transects. If it's smaller than 5 acres, which I think most of your sites are, you can do that, you'll do that transect generation in the field. But if it's large, we'll need a big random spread of transects. So just quickly, here's just this quick little explanation of what these different sites are. I think most of you will be looking at small fields like this assessment A, or maybe like a strip like assessment area B of restored habitat. And then, but you can also do roadsides. You can also look at in-field habitat strips. or do this on larger restoration areas or fields. So now we get to visit the site. Imagine we're going into the field. Hooray! Here are the steps. Again, I'll walk through all of these and imagine that I'm in my field hat and sunglasses and I have my binoculars because I'm a bird nerd and my clipboard and we're all hanging out. Here's the stuff you should bring into the field. Pretty standard field supplies. Data sheets, which we'll make sure you all have, but they're in the back of the user's guide if you want to reference them right now. Plant list or an ID guide. NRCS has a great important plant list that we recommend you use. And of course, if you don't have that in the field, it's best practice, as all of you probably know, to kind of write down, if you find a plant you don't know, write down a description of it, take a picture, and then you can ID it back when you're back at your office or house. Having a GPS and a thermometer are important. Also bring out the half square meter plat frame, which you can make out of PVC pipe. And I'll show you more pictures of that in a moment. And then if you can identify species, great. Oh, Eric's waving his frame around. Yep, the ability to ID species is great, but not necessary, and like a passing familiarity with native plants is totally good enough. So now we're traveling to the site. Deep, 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 deep. First step when you get to a site, at least when I do this, is you go talk to the landowner. Let them know you're there, let them know the plan for the day. Sometimes they like to come along, show you what's happening. Sometimes they're busy doing something else. But this is the chance to get out the base map, or get out that project map you made, show them where your assessment areas are, and really confirm those are the places you should be monitoring. So make sure you do that, especially if the boundaries aren't yet defined, or if you and the landowner had a misunderstanding about where the project was going to take place. And then just mark it on your project sheet for changing the map in the future. So then, depending on what your site is, there are 4 different field collection methods. These are each designed for specific assessment areas and to most efficiently capture robust field data. So we have 4 options just because there's a large number, lots of different kinds of projects, and we want this tool to be able to be used on all of them. So these are all outlined in the user's guide, and I think we'll have time to go through all of them today, but we're going to focus on number 3, that small patch method. I think the vast majority of your guys' projects are that small patch method, and it's very similar to numbers 2 and 4 also, just kind of translate design is a little different. But just so you know, if you just get out of your truck one day and see a beautiful patch of milkweed and it's 5 meters by 5 meters, you can do that number 1 individual patch method. So here's just a little flow chart. Again, if it's going to take you less than 20 minutes to count all the milkweed, just do that individual patch method. If it's right next to a road, a very long right-of-way next to a road, we have a specific roadside and right-of-way methodology. And then if it's less than 100 meters wide on the short side, you can do the small area method. Anything bigger than that, getting close to a couple acres, you should look at the large area method. So yes, focusing on that number 3 today. I'm going to dive into the small area method right now. And then, so just again, remember, now we're in the field. we're looking out at this beautiful restored California prairie, and we're setting up our transects. Now, once you guys get good at this, you can just pace these out. It doesn't need to be super scientific. The goal is to have 100 plats. So 10 transects, 10 plats each. Kind of eyeball how big your site is, and then just pace out one transect, do 5 paces, come back with the other transect. But to kind of do it formally, first step is you set your baseline along the longest edge of the patch, like so, boop, 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 boop. And then have a random start location for your first transect. So throw a pen, pick a number, pace out to your first transect, and then starting at the edge of the patch, run your transect. And again, we're aiming for 10 transects, 10 plots each, if you can. So the transect just runs the whole length of the assessment area. And you should record the length of the transect for on your data sheet. And then you do 10 plots spaced at equal areas. So once you figure out where your transect is, maybe walk it, figure out how many paces it is, divide it by 10, and then come back pacing for each subplot, each plot, excuse me. Eric, anything to add on transects?
I'll just add that this is one of the maybe more complex or tricky parts of getting started with the HQT. So feel free to reach out to us. We're able to kind of help you guys take a look at your site and make sure that you get it set up correctly before you go out into the field. But once you get the hang of it, you'll be able to do this pretty quickly.
Well, not just that, we actually have funding for environmental incentives to look at your proposed map. So we encourage you to try and come up with how you're setting up the sites and have them review it. If you, I think it would be great if you all did that.
Yeah, we love this stuff. We'd love to help. Great. So that's kind of our plot design. Then we get to collect our field data. First things first is we do a botany walk or a timed species assessment, and then we'll establish the transect and collect our plot data. So for the botany walk, it's a good thing to do when you first get to the site with your team. Maybe it's just you, maybe it's you and some friends you brought out, maybe it's you and Hillary came to visit. So you're out in the field together. So the goal is to walk around your assessment area and just see what's out there. See what's out there and then also agree on what things are, because you don't want 2 different data sheets with 2 different names for the same plant. That gets very confusing very quickly. So as a group, kind of walk around, see what's blooming, and write it down. And you'll write it down on your field sheet. Let's see if I can pull this up. Nope, wrong one. Never mind. You'll just make a list on a data sheet of all the plants that you see. And if you know their name, great. If you don't know their name, just decide what you're going to call it. So say you see this beautiful fiddleneck. Great. Write it down. I actually don't know the Latin name for the fiddleneck.
Incinkia.
Thank you. Incinkia. And then maybe you see a California milkweed, Asclepias californica. You write that down. And then maybe you see this little guy and you're like, shoot, that name's just on the tip of my tongue, but I can't remember it. And you just call it like pink small flower. But then everybody knows that this is the pink small flower and you should not call it something else. So then, yeah, you record all your nectar plants on your blooming nectar plant species section of your assessment area data sheet, which is the first part of your data sheet. And then if you see any, if you miss any, that's fine. Just add it to the bottom of the list when you do see it in the future. Kind of whether or not it's in a plot, if you just happen to see another one as you walk around, add it to the list. So this gives you a good dictionary for everyone to use as you do your plots. Oh, yeah, this is just a note. Say you find something you don't know what it is, take a picture of it, say this is going to be called unknown number 3, and then when you're back in the site, back at your office, you can identify it. Just as long as everyone knows that it's unknown number 3. Okay. Yeah, so for example, here's our blooming forb species data sheet, and we would just fill in the Amsynchia, the Asclepias, and this unknown pink, small pink flower, and agree on the abbreviation. So the 4-letter abbreviation, and then for this pink small flower, I just abbreviated PISF. Great. Then you establish the transect, like we talked about. Use your baseline. Go from one end of the assessment area to the other. And then we get to get out our data frames. Everybody loves walking around with a giant frame of PVC piping, I know. So that for this Monarch HQT, I will give kudos to the tool designers for coming up with a very clever frame design. And the frame is 1 meter by 1/2 meter. So you put that down on one side of the transect, and then you flip it over, hamburger style, to the other side of the transect. So you end up with a 1 meter plot. We'll go through that in more detail in a moment. Within each plot, you measure milkweed density, milkweed diversity, blooming nectar plant frequency, and diversity. And you fill out this data sheet. We'll have our blooming nectar species here along the left, and then our first plot along the transect will be here, and then each transect will have 10 plots. You'll do blooming forb availability, and then second you'll do milkweed density, and we'll talk about each separately. So just as an example, if we were using that data sheet we just came up with sail neck and Asclepias californica and our small pink flower, which is the name I actually did know, but now I forget. This is what a final data sheet would look like if these were the only 3 flowering plants we saw. But now we're going to walk through a hypothetical plot with a lot of clip art, so I hope you guys are excited. This is us, hanging out. So we've done our botany walk and our timed species assessment. We're going to establish our transect. There it is, great, check mark. And now we're going to collect our blooming nectar plant data. So first thing first, plot 1, we walk our random number of paces and we lay down our frame on one side of the transect. Now the frame is going to be composed of 3 different subplots. We have subplot 1, which is the leftmost half of the frame, subplot 2, which is the right half, and then you'll flip the frame over and that'll be your subplot 3. This makes a total plot size of 1 square meter. So for each species you see, you record the smallest area in which it occurs. So if you see it first in subplot 1, you write down 1. If you see it in subplot 2, if you see a new species in subplot 2, you write it in subplot 2. But if you've already recorded it for subplot 1, you don't write it again. Similar for the third subplot. So for example, say we've done our botany walk and we've come to find these 5 species on our assessment area. Note, we should in here be having our abbreviations just to make our data sheet more legible, but because it's more fun to have my made-up names, we'll keep it with that. So we lay down our data frame, and in our first subplot, we see these flowers. So I'm going to try and edit the slide while you guys tell me the answer. So what do we write down in our data sheet? What do we see in our subplot 1? And you only write down if they're there, not how many there are.
Kristen, I know.
Let's hear it, Eric.
I see California poppy in subplot 1.
Great. So we would write just a number 1 in our field sheet under plot 1. This whole thing is plot 1, but it appears in subplot 1. So that's all we write. And then similarly, we also have that sunset fiddleneck. Oh,
Okay.
excuse me, not in subplot 1. So then you move on to the second subplot. Oh, spoiler alert. So then in subplot 2, we have the fiddleneck again, but we don't write it again. We don't write it in subplot 2 because we've already captured it in our subplot 1. Similarly with this California poppy. This guy, this black and white spot, just doesn't count. It's just right outside the plot. It looks cool. Wish I could count it, but I can't. And then as a trick, we have this pink stem whose bloom comes into subplot 2, but we don't, we only count rooted individual. So we wouldn't count this flower in that plot. We count it where its roots show up.
Okay.
Fortunately for us, its roots show up in subplot 3. So at this point, we flipped the frame over to the other side of the transect tape. Oh. And can anyone tell me what I record in our fake data sheet?
The pink stems and the aster.
Hooray! So yes, pink stems gets a 3, and the aster gets a 3 also. And we don't change our California poppy record because we already have it captured in our plot 1. Great. Thanks for walking through that clip art with me. So what do you record? You record things that are a nectar plant, and if they're blooming, and if the roots are within your frame, are within the plot. So here's a speed round quiz. Would you record these 5 spots if you saw them? Yes, you would. Would you record this Mariposa? Oh, Hillary, nice Zoom reaction. Would you record this Mariposa lily, one of my favorite flowers?
Yes.
Yes. Would you record this purple needlegrass?
Ooh, I don't know.
No, you don't. You only record things that have nectar available for monarchs. So even though this grass is cool looking, don't record it.
I wonder if we should open the chat box and then people can answer quickly that way without having to unmute. Would that work?
Sure. I'm not sure.
Maybe I can do it. I don't know if it'll work. Let's see. No, you probably have to do it. Oh, you can do it while you're sharing. Never mind. Oh, Pete's telling us we can create a poll. Oh, I don't know how.
That's beyond our Zoom capabilities.
Thanks, Pete.
All right. Great. Final question. Say you're walking around a beautiful field of California poppies, and this poppy came into frame. Would you, when this was the only poppy there, would you count it? Yes or no?
No, right?
Correct. Thanks, Nancy. You'd only count things that are actively blooming. So this poppy would not get recorded on our sheet. Great. You guys want to do another one? Or you're feeling pretty good about it? I'll just do it really fast. Remember, we're using abbreviations, not these fake names that I made up. So this is now subplat 2, as you can see. So we just move one line along the transect line. Or excuse me. We move forward along our transect line and we move one row, one column on our data sheet. So anybody, any brave soul want to take a stab? And I would suggest you start with just looking at subplot 1 and then subplot 2 and then subplot 3. But I made it hard because now you can see them all at once. What do I write for California poppy? Ooh, people are chatting. Love it.
Yeah, do a thumbs up. Let's see.
Great. Yes, Hillary, 2, correct. What about for sunset fiddleneck? 3, great. What about for the pink stems? Trick question. There isn't one.
Oh.
What about for the magenta aster? That pink guy. 2, nice work. And then what about for a black and white spot? 2, great. Thanks, Pete. All right, looking good. So we're filling out this data sheet. See how fun and fast this is? And remember, we're not counting grasses, and we're only counting things that are rooted in the plot that they're in. So great work. Good job, everyone. We've done our blooming nectar plant availability. Now we get to look at milkweed density and diversity. So for milkweed, we don't look at the subplots. We just look at the full 1 square meter plot, and we record the number of plants and stems for every milkweed within the plot. So this time we don't have to worry about these subplots, and we just look at this whole enchilada. So for example, say we had our Asclepias californica, and they were distributed like so in the plot. And this is, now we're on plot 3 because we just did plots 1 and 2. Now we're on plot 3. There's no other nectar plants. There's only Asclepias. We're in plot 3. There's 4 plants, and each of them have 1 stem. So there's 4 stems. And that's all you got to do for monarch or milkweed, excuse me. So there are a couple caveats. 1, if it's blooming, it gets counted both as a blooming nectar plant and as a milkweed. So back to our little data sheet we just filled out, and back to plot 3, we would write in Asclepias, and we would put it in plot, it would get counted in plot 2, because that's the first subplot we see it in this plot 3. But we would also have it on the milkweed side of the data sheet. So a single milkweed plant can have multiple stems. I think most native plants and milkweeds in California are kind of a 1 stock situation, but there's a couple that branch, and so then you'd count it as 1 plant with multiple stems. However, some milkweed, like the common milkweed, which you don't have in California, but I think there are other ramette-forming milkweeds in California, do this thing where they grow ramettes. They're above ground stalks, and you can't actually tell if they're 1 plant or multiple plants. So for those, you just count each stem as a plant, because you can't tell. For example, this is all 1 plant here on the left with 9 stems, and here on the right is probably actually 2 plants, 1 with these 2 stalks and, or excuse me, these 3 stalks and one with these 6 stalks, but it's too hard to tell. It's underground, so if you look down and you can't see an obvious bifurcation of the stems, then you just count it as each as a separate plant. Great. I wish I was in the field to show you how this actually looked, but you'll have to deal with that picture. Congratulations, we've done all of our field data. We collected plant data. For each plant, we did nectar plants and milkweed. And now all we have to do is do this 9 more times for this transect, and then for 9 more transects. Great work. So our data sheet now, this is our fake clip art data, is beginning to look like this. We have our California poppy, our sunset fiddleneck, and we're moving on to plant 4. And we've seen our Asclepias californica one time. And all you gotta do is repeat for the rest of the assessment area. No prob. It does end up going very quickly, so don't be intimidated. We're halfway done with our 2-hour webinar, so I'm going to take a 5-minute break, and I recommend everyone stand up and flap their arms around, and I'll start again at the top of the hour. Get some water.
I wish we had, it must be really hard to be talking to all these. You don't know if anybody's listening.
You know, if they have better things to do, I understand. No,
We're listening. We're listening.
it's just it's our current state of affairs.
Yeah, and I think if we have I think I turn my video off because it's distracting to have, I mean,
Sure.
you to see the speaker, but I'm sure everybody else has done that too.
Yeah,
I'm
I
also so
definitely get
sick
what
of
you're
seeing
saying.
myself. We're all tired of seeing ourselves all the time.
Totally.
Oh,
I
I
definitely
think
get like Zoom fatigue at the end of the day.
God. Yeah.
I think the hardest part for me is telling a joke and then hearing silence, and it's not because it wasn't funny, but yeah,
You still want some feedback.
right. It just wrecks your confidence.
Although for me, looking at myself all day long is wrecking my confidence too. So
Yeah. It's a
I
weird
remember
world. Weird world.
back in the day when people were talking about having video phones at home, because I've been working at home for like a really, really long time. And I said, I will never, ever, ever do that. And here we are.
There you are.
Did you see on where I saw this on like Facebook or something? One of the newscasters, like a local newscaster, was giving his report but wasn't wearing any pants, and the screen was just a little bit too low, so you could see that he was just in his boxer shorts and a blazer and tie and everything, but wasn't wearing pants.
About that. Oh my God.
That's funny.
There was we were having a meeting and someone said that there was a guy in the meeting who I guess he thought his video was off, but he like pulled his pants down, and it wasn't like he wasn't trying to be, it wasn't on purpose. It was
just accidental. Oh no. That'd be bad.
Well, it's hard to control your facial expressions too, like rolling your eyes at people.
Oh, totally. Or just my confused look.
Right.
Looking confused. All right. We got 1 minute left.
I'm gonna hide myself again.
Great, no worries. All right, thanks all, and nice use of the chat box to answer my pop quiz questions. I don't think we have any more pop quizzes, but feel free to, if you have a question, pop it in the chat. I might answer it, or I might just table it for the end. But do whatever you want. Great. So we're done with our site visit. We've done our 100 plots on our assessment area, and then if we have another assessment area, we do the same thing in that assessment area. We pack up all our gear, we drive back to the office, and we move to step 3, doing the desktop analysis. So the first thing to do in the desktop analysis is to understand the threats to each of the assessment areas. And in our current version of the HQT, this just means, is it within 125 meters of conventional agriculture? So you pull up your map of the site. Here's all of our project areas again. You identify your threats. Oh, here's a giant field of conventional ag. Here's a giant field of conventional ag. And then you highlight where's the threatened area. Oh, I guess first you calculate your area, acres per site. Locate nearby threats. And then we zoom in a little bit. We calculate area of habitat risk, within 125 feet. I said meters before, I meant feet. So you highlight anywhere that's within 125 feet of conventional agriculture. That at-risk acreage is highlighted here. This whole assessment area B is at risk. Parts of assessment area A. Remember, we excluded these parts of assessment area A because there was a pond in the hedgerow. And then parts of C are also at risk. But then there are mitigating factors that you can consider, like hedgerows. Hedgerows work really well to keep pesticides out of pollinator habitat. So then you calculate the area of that at-risk area that is protected by things like hedgerows. So turns out this area in A has a hedgerow next to it, so it's actually protected. So those things you'll enter into the HQT calculator. You'll enter the full assessment area acreage, you'll enter the at-risk acres, and then you'll also enter which percent of those acres are protected by a hedgerow. You'll see B and C, there's no protected acreage. So when we published the Western Monarch HQT Users Guide, we included this threats module, which actually isn't part of the calculator. So as you were scrolling through the Users Guide yesterday, you probably saw this table 2, which talks about threat mitigation scores based on integrated pest management strategies. And this is based on Xerxes technical note number 9, to how to figure out how to calculate a threat mitigation score. And it's a cool way to kind of integrate these two tools. So I don't know if you guys are familiar with that Xerxes tool, but know that this is a cool thing that hasn't been built out yet, but has been thought about. And if you're interested, we can kind of do a deeper dive into that at the end of this presentation. But just know if you see this in the user's guide, don't get very confused. Just think about the calculator takes into account at this point this acres that are within 125 feet of agriculture and also hedgerows, and then doesn't take into account these IPMs and other mitigating factors. So apologies for that slight confusion, but know that this could be a future version of the HQT. That seems like a cool component that both Eric and I are interested in building out. So that's the end of the desktop analysis, and then you enter your threat scores from your desktop analysis and your site data into the HQT calculator. So don't worry, I'm going to switch over to the Excel sheet and walk you through that, so you won't have to look at tiny tables for much longer. But just know we're taking our field sheets and we're putting it into our Excel sheet so it can sum up our weighted scores, and we can talk about that functionality score and functional acres for each assessment area and each project. As I said, the purpose of the HQT calculator is to take those data sheets, store them digitally, and then calculate our habitat quality score for each assessment area. And then we average, using a weighted average, those assessment areas into a site score and total functional acres per project. So I am going to switch to this Excel sheet, and I know it's really fun to see Excel sheets. So apologies if it's small, but I should have sent this earlier, but I forgot. So I'll send this to you immediately after this presentation. This is our Western Monarch HQT calculator with just some fake data filled in, so you can see kind of how it works. So just as a structure layout, can somebody give me a thumbs up reaction if they can see the screen okay? Thanks, Eric. So just as a little orientation, we have our instructions tab as the first tab, and then we have several tabs along the bottom. Blue tabs are for site visit data. The red tab is for our threats analysis, our desktop analysis. And then we have some back tabs that are just kind of extra information and also how the sheet works. So we'll start at the top. And each of these Excel sheets has guidance at the top, so don't just skim over this. This will be helpful information for you guys to figure out how to compare your data sheets with what goes in each tab. Tab 1 is just pretty basic information about the site and the assessment area when you did your assessment. Tab 2 is you copy that blooming Forbes list that you made during your botany walk, all the species you saw on each assessment area, and you put it in here. So this is your chance to take your common name or your pink flower number 6 and figure out what it actually is called. This is also the time when, and I should have mentioned this earlier, if you're ever in the field and you see a tiny little flower and you're like, how the heck could a monarch use this tiny little flower as nectar? Be better safe than sorry, and write it down, mark it when you see it in your subplots, and then if you go back to your computer and you decide, you know, we're actually not going to count this flower in our assessment, that's when you would like mark it here in the notes and discount it from your plots. Better collect the data in the field and then delete it late and then not include it later than just not include it while you're in the field, because you can never get that information back. And then we have a column here for native, invasive. What does B stand for, Eric?
I actually forget. I'll get back to you.
Great. Well, let's get back to everyone. Whether or not the plant is native. This tool does not discriminate against native or non-native plants for several reasons. 1, monarchs certainly use plants that are not native. 2, there's like a lot of different definitions between non-native, invasive, weeds. So in order to be more welcoming, we suggest you include every plant, every blooming nectar plant, and then perhaps as the RCDs, you can decide, okay, we're not going to include certain noxious weeds, or okay, we're not going to include this plant that does not provide value to the monarch. But for the time being, we recommend you include everything. Yep. So this is the tab where you just write down all the plants that you saw, and you'll see you write down what assessment area you were in. So just copy that data sheet from your assessment area, and then your next assessment area, you'll repeat the same thing. Great. So then tab 3 is just any notes about the management area, management of the assessment area you may have, when it was mowed, if there's nearby agriculture, etc. This doesn't get built into the score at all, but it's a good place to capture that section of your data sheet. And then tab 4 is when we get to the transect data. So tab 4, you write the transect information, a unique transect ID for each transect, who was the recorder, who are the observers. Ideally, you have a GPS point, and then how long your transect was. Form 5, you get into the flowering plants. And here, importantly, you just record this bottom box at the bottom of your data sheet. So anyway, it's at the bottom of your data sheet. You'll see that it, here we go. My Zoom. Okay, so here's an example data sheet. This is scanned in from a real site visit that we did. You'll see we saw all these plants, and then this bottom box, you just record the minimum value for each column. So this represents the subplot in which any blooming Forbes species was found. So for our first plot along the transect, we saw a couple Forbes species in subplot 1, that very first smallest subplot. For number 2, we saw the first flowering plants we saw were in subplot number 2. We saw black-eyed Susan and hot flower there. So it is this box that you record in the calculator. as it says right here. You'll note that there probably will be a bunch of zeros. If you're on a site that doesn't have a lot of pollinating blooming nectar plants, which most of the times that I've done this, there have not been a lot of blooming nectar plants. So don't be afraid of zeros. So this captures forb availability. Forb diversity is captured by that blooming forb species list. Great. I see some questions coming in. Thanks for those. And Sarah, just to see, what do you recommend, or what do we recommend to figure out if it's a nectar plant? Pretty much if it's a flower, it's a nectar plant. If you're wondering about that in the field, I would say count it. It's often hard to imagine like monarchs are using dandelions, but our current protocol is that you would include like a dandelion or another weed as a nectar.
Actually, dandelions are really commonly used by monarchs near overwintering sites. I have tons of pictures of one. But yeah, so Sarah, I also would say like any plant that like you would provide nectar is blooming, I would include that. Xerces does have a list of like recommended plants to plant, which I can send out, but I would not limit this to just that.
Great. So thanks for your question. And those of you who have just joined us, I'm sorry you are a little late, but this has been recorded so you can catch up on the first half of the presentation. And just for orientation, we're going through the Monarch HQT calculator right now.
Kristen, while we're taking questions, Sarah had another question. It's if we haven't planted a portion of our project yet, do we include that area in the survey?
Do you want me to answer that?
And I'll take a stab at it. I would say it depends on whether you want to differentiate that site over time with your data. If you don't mind, your first year's data is going to include some area that's not planted and some area that is. It might just make it easier to do your monitoring over 10 years. By year 10, it probably won't make a difference. But if you did want to treat those two areas differently or have data that you could disaggregate between the two plots, you might want to set up two assessment areas. So it's really kind of up to you.
Okay, thank you.
Yeah, and I would just add that it would be cool to see the change over time if you went from a unplanted baseline to see what it would show up in a couple of years with all your cool native plants. All right, moving right along to tab number 6, milkweed availability. And this is where you translate that side of the data sheet that just has the milkweed species, what plot it's in, the number of plants and stems, and you simply write in your assessment area, what unique transect ID you are on, which will be on the data sheet, what species of milkweed it was, and then just directly copy from the data sheet into here. Finally, the desktop analysis. As I said, first step, calculate the acreage. Second step, calculate that at-risk acreage, the acres that are within 125 feet of conventional agriculture. So you'll see in this mock example, about a quarter of Monarch Ridge is close to some other conventional ag, but 25 of those acres are protected by a hedgerow, or several hedgerows probably. That's a lot of acres to be protected by a hedgerow. Great. So that'll be calculated as part of the score. And you do get dinged for this habitat at-risk acreage, but less dinged if it's protected by a hedgerow. So yeah, as I noted before, that other module based on the Xerces Technical Note 9 would allow for a little bit more manipulation and including other factors in this mitigating factors thing. But right now we just have none or hedgerow as our option. Great. I know you guys are all excited to see what the assessment results are of this fake project that none of us have ever been to. So this is the calculator, and it takes all that data you'd entered from those first 7 tabs and combines it here. So it rolls up each assessment area and looks at, I'll zoom back in a second, site capacity, threats, conservation priority, and then it gives you a final habitat quality and functional acres for each assessment area. And again, this is that Monarch yield estimation, that 70 Monarch per functional acre, which again, I would say is just a communication device. You should always caveat it by saying it's just a model and an estimation. So I realize one thing we haven't talked about yet is this conservation priority score. And we have built this as a functionality into the tool, but as to date, we have said every single site that uses this tool on has 100% conservation priority, because we figure people are doing Monarch projects, we want to encourage them. However, if the RCDs want to, as a group, kind of define what they mean by conservation priority, you guys could, you or others could create a way to prioritize each project. You know, is it near overwintering habitat? Is it a lot in certain areas where you know you need more Monarch projects? Geographical, spatial, temporal, you can think about all sorts of things that can be included here. But no, for now, everything's set at 100. So there's no differentiation. Great. So you'll see for this project, we did 5 assessment areas. This first one, which was called Monarch Ridge, is 65% functional. And the second one, which was called Boysenberry Patch, because my last name's Boysen, is 40% functional. And the other ones are not functional. So they don't have any functional acres. So that's all well and good, you say, but what about the whole project? What if I have a project site and my farmer's like, I don't care what each field is, I want to know overall? Don't worry, we have a beautiful summary tab right here in the front. So you'll open it up when you're talking to Hillary or your landowner or the Solano Irrigation District, and you'll say, great news, you have a breeding habitat quality score of 30 and a foraging habitat quality score of 46 and an overall score of 34. Threats, you do have some at-risk acreage, but a little bit of that is protected. So you have a bit of a threat score. Lower is worse. Conservation priority, you're such a priority for us. Great news. And then overall results, we've assessed 650 acres with 184 functional acres. So this little workbook is a good way to kind of walk through the site and also to dig into what could be the factors of different things. So I'll kind of get into how to interpret these results next, but before I switch away from the Excel sheet, does anyone have any questions or want to see something again? Great. So yep, we have a little summary tab. We just saw that. That kind of rolls up all your information. And then you get to review your results. So you have, as I said, your assessment area results are broken into breeding, foraging, threats, and site capacity, and then also your full site results, which are weighted by each assessment area's area. Weighted by the acres of each assessment area. That's a better way to say that. So what does it all mean? Good question. So you can definitely use the HQT to compare one site to another site, one assessment area to another assessment area, but it's also worth digging kind of one layer deeper. It's worth looking at the breeding score versus the foraging score, because that, I mean, especially in California, and I guess especially everywhere, there are some places that have a ton of milkweed and some places that don't have any, but that doesn't mean it's not good foraging habitat. So not every site's gonna have both, and if you have great foraging habitat and bad breeding habitat, your score is still gonna get averaged. So if you're planting specifically for one or the other, don't look at the full site score, just look at the targeted one you're working towards. If you want it to be breeding habitat and you plant a bunch of milkweed so much that it blocks out all the other blooming plants, then you just focus on breeding. Don't worry about if your foraging score is low. So second, consider where the site is. If there's a bunch of foraging nectar sites around, focus on breeding habitat. And likewise, otherwise, if there's a lot of, like it's a monoculture of Asclepias californica nearby, maybe plant some other native plants to increase habitat for monarchs and others. The threat score is a tricky thing to change, especially if the neighboring land is not owned by your landowner, but it is worth considering how hedgerows can be used as a mitigation technique, and how perhaps if you have a whole farm and a willing landowner, you can place your project slightly farther away from their conventional ag fields just to increase, so that the score is increased. And then if you have a big planting project, which I know many of you do, like think about that species diversity. We use the Simpsons Index here and really narrow in on that indicator to see how it changes over time, because that's important for a lot of different species and can be used to see how if your planting is successful, or if you're creating more of a landscape with one or two species that are thriving. Eric, anything else to add?
Nope.
Great. So as Hillary said, you guys do have to monitor every 10 years, or no, every year for 10 years. So there's a lot of ways for that to be tedious, and also a lot of ways for that to be cool and create a cool data set. So the nice thing about the HQT is that it does allow for clear monitoring over time and understanding of what's happening on the site. So if possible, try and use the same transects every year. Using a GPS point at the start of the transect with a clear bearing is a good way to do that. Probably can't, well, it depends. If it's the whole site's a restoration site, you could add little wooden stakes or something to mark the start of a transect, but sometimes that's hard on private land. Capturing baseline data, like Sarah mentioned, on a site that hasn't been planted yet, or on a site that is going to be fully redone, it could provide interesting data on improvement over time. And then try to do it, during that peak milkweed and peak monarch time, which will change every year because of climate and also climate change. But repeat the sampling if conditions change significantly, either because of climate or because there was a fire or the landowner did something crazy with their management plan. so it's good to do it annually when you're supposed to do it, and then also do it again if you can, if something wild happened. And I'm very excited that this tool is being used by you guys on all these projects, and can't wait to see the fun data sets that you create. As Hillary and Eric said, we are available to help figure out sampling protocols, when to be sampling, what you should be looking for, walk through the whole frame thing again. So remember, we are at your beck and call. Great. So I think that's about it, except for the other sampling protocols. So I'm gonna give everybody a minute to think about what they've heard and ask any questions if they have them. And then I'm gonna ask, and then we're gonna talk about some more stuff.
I had a question about, so when we're doing the plot surveys, we're only counting plants that are rooted in the plot, correct?
That's correct.
Okay.
So, yeah.
So we have a lot of large shrubs slated to be planted. And so, you know, there's like 5-6 foot spacing. And so a lot of that stuff is going to get missed. I mean, there's really no help for that, right?
Right. So you'll count the large shrubs in your, during your botany walk on your what plants do you see there.
Okay.
Yeah, so they'll be counted there. And then, right, the idea behind the sampling technique in the transects is that you can capture plant abundance. So if there's only a couple shrubs, you're right, they probably won't be counted by the frame. But even if they sneak in 1 or 2 frames, then they'll be well represented in the statistics.
Okay, that's good to know. So oh, go ahead.
Well, I would just add, I think shrubs are kind of a difficult one because they obviously have a small root area and from the trunk, and then they provide a lot of nectar resources. So, you know, one thing you can do is take pictures of your transects. I encourage all of you guys to take pictures of your sites and your transects to better capture that. And then, yeah, just keep that in mind. If you may end up moving through the site and not actually capturing one of those. And so that'll, you know, shrubs are a difficult portion to capture with the root frequency method.
And would you recommend, sorry, I was just going to ask if you would recommend, because it is a small area, there are individual planter beds that we'd be surveying. So is it wrong to skew your transect line so that you do capture those, or I don't know. Seems like bad science, but.
Right, you have a couple options there. I think if you're really, sometimes, you know, when we're talking about fairly small planter beds, you might just want to count the milkweeds and then get the species list rather than doing transects, because it'll be hard just to fit the number of plots in there, depending on the size. The other thing, if it is big enough that you can fit the plots in, just make sure that you're evenly distributing those frames, those plots into your site in kind of an even probability way, just doing a probability sample, and then don't generalize to the areas between your plots. So just say we have, you know, a few 100 square meters of habitat and this is its function, instead of saying that the interstitial spaces or the spaces around where you're planting are that same quality. Alternatively, you could sample everything. You're going to have a lower score, but you'll have more area over which you're calculating that function.
Okay.
And what Kristen and Eric both have alluded to, I think Kristen's going to show this next, but that there are other methods for sampling that they've come up with for the HQT, one of which is if you have a really small area, you do just count everything. And then another is for like a roadside or a linear habitat. So something similar to what grasslands RCD is doing, and that method is just slightly different. And so I think that's what Kristen will get to next. Yeah.
Great.
Awesome. Thanks for the questions. So yes, good segue also. I do want to talk about the other sampling methods. So you'll remember I was talking about this flow chart and we really focused in on this small areas method, but there are 3 other options. So there's an individual patch method, which Eric said could be an option for your single bed. There's also a roadsides or right-of-ways method for very long strips, skinny strips along roads. And then there's a large area method for things that are kind of too big to just do our 10 transects kind of in a standardized way, and then you need to randomize them. So I'm going to walk through 1, 2, and 4 right now, and then also Eric and I are going to stick around for the half an hour after this call. So if you have, like Sarah, kind of specific or unique project designs, we're happy to kind of talk through how you might sample that best. So just for example, here's our map again. For A, we did that small areas method. For B, we're going to do an individual patch method because they're small enough to do that. For area C, this very long skinny thing here, we're going to do our right-of-way method because it's so long and skinny, and you couldn't possibly fit 10 plots across it on your transect. And then for E, we're going to do our large area method. Right. So for the individual patch method, if it's less than 500 milkweed stems and an area you can kind of all see pretty close to each other, it's not going to, it's not going to take that long. You can't really imagine how you would fit 10 transects in it. You forego the frames altogether and you walk around your patch, you count all the milkweed plants, and you record all the forb species you see. So essentially, you do an intensive botany walk, writing down all the milkweed species and individuals, and all the forb species. This is essentially saying, hey, this individual patch, we're gonna know everything that's in it that's useful for monarchs, and we don't have to statistically sample transects because we can just know the truth. So that's what these guys are doing. They're just looking around for all their plants. All right, number 2 is the roadside and right-of-ways method. And if you guys get really into this and are doing a lot of road sampling, we have a whole nother tool specifically designed for this that also has a Survey 123 app. So ask me questions about that later if you want. So in our little graphic here, this is the road strip down here. For safety and access, the side of the road is often mowed. And then you have your habitat patch. So this mowed edge will serve as the baseline. And the idea is to run short transects, 25-meter transects as they fit, from one edge to the other, and still 10 plots per transect. So the idea is to kind of crosswise it along the right-of-way with shorter transects. Other than that, it's very similar to the individual patch method. You still collect milkweed abundance, milkweed diversity, flowering, nectar plant, frequency and richness, like we discussed. So again, this is just if you can't really imagine getting your 100 meter transect across the whole thing. if it's a skinny plot, you can angle in these transects like so. Eric, any additional thoughts?
Yeah, I think this is very similar to the small areas method, except as you can see, the transects are just laid on their side a little bit. You can use 25-meter transects. You can do 50-meter transects. The transect length doesn't matter so much as just making sure you get 100 plots arrayed across the assessment area. And really, that's what these different methods beyond the individual patch method, which is a little bit different. These methods are just trying to help you get your transects spaced out on the assessment area in a even and equal probability way.
Excellent. And so then the final method is for a large patch area. And so, so here's a good picture of what a right-of-way might look like. So you have the road over here on the right, and it's just a tiny little patch, or a skinny little patch here. So probably 25 meters might not even fit. You might have to do 15 meters or something. Beep, 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 all the way down. 100 plots. Okay, finally, you have your large area method. And this is for plots greater than 5 acres, approximately. To do this, it's best if you can generate random transects prior to visiting the site, because the site's so big that you don't really want to or trust doing the crosswise small areas method where you go from one side all the way to the other. In fact, it's probably unlikely that you can do that. So instead of doing it while you're in the field, you randomly generate 10 starting points for standardized transect length. It can be any size you want, as long as you have 10 plots per transect. So say you're doing 10 100-meter transects, just like we do for the small area plot, 10 plots per transect. But instead of having them uniformly across the whole site, you kind of have these randomized start points. So this is to, randomize our survey, make sure you capture across the whole assessment area, because especially big ones can really vary from side to side, edge to edge. This does require using some software, be it GIS or Google Maps or some other way to randomize spatial points. And then using a compass while you're on site to go to the correct bearing, because that will also be randomized, which direction you leave from your start. Other than that, it's the same. Other than that, you use your 10 frames per transect, and you measure milkweed diversity and frequency and nectar plant richness and abundance. Great. So that's that. All 4 of those sample methods are in the user's guide, and you can talk to Eric and I or Hillary anytime you want. Again, these are the 3 components. We'll make sure you have all of them right after this call, and you'll also have the slide deck, and you'll also have this recording of this presentation. And then here's some references. And then you can also email me. I'll probably get back to you faster than Eric will, but you can also email Eric. Sorry to throw you under the bus, Eric. And we'd be happy to take any questions about this presentation, your site design, anything else, status of the Monarch butterfly. So that's all I have. We still have 15 minutes left of this session, so stick around if you have questions. Don't stick around if you don't have questions.